Hello everyone, we are going to see about recursion. Recursion is a programming technique where a function calls itself in order to solve a problem. It's a powerful concept that allows solving complex problems by breaking them down into smaller, more manageable subproblems. The key concept base case, every recursion function must have a base case which is the simplest possible case that does not require further recursion. It prevents the function from infinitely calling itself, and then it has recursive case. The recursive case defines how the problem is broken down into smaller subproblems. It involves calling the function recursively with modified parameters, moving closer to the base case with each recursive call. The advantages of recursion: simplicity. Recursive solutions are often simpler and more elegant than their iterative counterparts. Divide and conquer. Recursion naturally lends itself to divide and conquer strategies, making it suitable for problems that can be solved by breaking them into smaller parts. Readability. Recursive solution can closely mirror the problem description, making them easier to understand and reason about. The disadvantages: performance overhead. Recursion may have a performance overhead due to the function call overhead and the potential for stack overflow when dealing with larger inputs. Debugging complexity. Recursive solution can be harder to debug compared to iterative solution, especially when dealing with multiple recursive calls. Now I will going to show you the code, how it will work in the code using for factorial. For that I have created a factorial.java file. Inside that I am going to create a public class factorial. Public static int factorial int n. First we are going to write a base case factorial of 0 is 1. So that I am going to write if n equal to 0, then return 1. Recursive case factorial of n is n into factorial of n into n factorial of n minus 1. So that I am going to return n into factorial of n minus 1. Now I am going to write a public main. String arguments int n equal to 5, int result equal to factorial of n. System.out println the factorial of n is if I run this, the factorial of 5 is 120. The factorial function takes an integer n as input and returns the factorial of n. In the base case, if n is equal to 0, we return 1 because the factorial of 0 is defined to be 1. In the recursive case, if n is not 0, we recursively call the factorial function with n minus 1 and multiply the result by 1 by n. In the recursion continues until the base case is reached at the which the point the function returns 1. Time complexity of this recursive approach is so often because we make a single recursive call for each integer from n down to 1, resulting in n. The total function calls. This recursive approach elegantly computes the factorial of number but may encounter stack overflow error for large numbers of n. To handle large inputs, an alternate or tail recursive approach may be more suitable. The tips for using recursion: identify base case. Always ensure that there is a base case that stops recursion. Test with small inputs. Test recursive function with small inputs to ensure they terminate as expected. Avoid redundant work. When possible, use memorization or other techniques to avoid redundant computation in recursive function. Recursion is a powerful tool in a programmer's toolbox, but it should be used judiciously and with care to avoid pitfalls such as infinite recursion or performance issue. Thank you.